3.2, number 68. The question says to find f of x and x equals a for the following limit. And that limit is known to be a derivative, which represents a derivative. And the one in 68 specifically is the limit as h approaches 0 of 1 plus h to the 2/3 power minus 1 over h. A lot of this is a purely visual thing. I'm just going to compare this with the definition of a derivative. Right? In other words, this is f prime of a for some function f and some value a. That's what their claim is. The structure represents a specific derivative. So if that's the case, then I should be able to compare it with the definition of a derivative in the abstract. Anticipating. And by this comparison, I should be able to sniff out, in a sense, what f and what a are. So just looking at the structure and comparison, well, there's h, limit, h goes to 0, so that's obviously the same thing. It's when you get into the numerator here, you start to see what represents what, perhaps. So it looks like f of a is represented by the number 1, right? First of all. That looks pretty straightforward. F of a equals 1. And then it looks like f of a plus h is 1 plus h to the 2/3 power. Right? If that's the case, if f of a plus h is 1 plus h to the 2/3 power, then it looks like a is being played by 1. Right? So these two things together imply pretty much, a reasonable guess is that a equals 1 in this context. So I see a plus h, I see 1 plus h floating around in here. And then the function that's happening to this 1 plus h, what function is happening to the 1 plus h now? Looks like the 2/3 power function. So my guess for f of x is the 2/3 power function. And the only thing I would do to solidify this, just to make sure that this extremely reasonable guess is correct, is to find f of a itself. So a is 1 in this case. So f of a, according to my guess, would equal f of 1. But f of 1 would be 1 to the 2/3 power. But 1 to the 2/3 power is 1. So therefore I see f of a is 1, as we said back here. So that pretty much guarantees that I have the right a, right, and the right f. So that would be our answer to the question. That really, this limit is nothing other than the derivative of this function evaluated at this location. In other words, this limit is nothing other than the slope of this curve at x equals 1.